So hello students. So hope you are doing well. So we are posting lot of questions, MCQs, previous year question of different companies of campus placement and off campus placement of test questions. So we have posted lot of questions like 50 questions of digital electronics recently on our LinkedIn page, and we have not shared the answer. So in this video we will share the uh, what is the answer of the like questions we have, right? And so this is the video about the that only, right? So we have the first question for the asynchronous counter using T flip-flop. If the progression delay of each flip-flop is 50 ps and fan out adds to be 20 ps, 20 ps loading per stage, what is the minimum clock period for 6-bit synchronous counter? Then we have the options like 50 ps, 70, 420, 420 plus setup time, 50 setup time. So answer of this is, I guess, yeah, answer of this is each uh, each stage adds 50 plus 20, so it's 70 per stage plus into 6 and plus setup time. So total answer is D. D1 is, yeah, this one. Answer for this is this one. You can see the solution here also. Sorry, solution is here. It's simple only, right? Delay of each flip flop plus fan out of each flip flop 70 into 6 because it is 6 stage plus setup time, right? That is simple. But that are asked in different companies, so we are discussing it. A, a CMOS NAND gate has a one PMOS with a W by N ratio 2 and 2 NM NMOS in series, each with a W by L ratio 2. Assuming the mobility ratio is 2.5, what is the true? Which statement is true? Rising time equals to, almost equals to the fall time. Rising time is greater than fall time. Fall time is greater than rise time, and the noise margin is equal, which is true, right? So basically the W by N ratio is equal, but the thing is mobility ratio is one factor and other factor is they have the one, and here you have the two in series, right? Okay, so yeah, uh NMOS takes slope down, no, right? So rise time depends on the PMOS strength and fall times depend on the NMOS, right? So correct answer for this is this, right? B. Rise time is greater than the fall time, right? Yeah, B is the correct answer. Rise time depends on the PMOS strength and the uh, because we have the here we have the PMOS. Okay, great. Yeah. So rise time is greater than the fall time. Yeah. Weaker. So B is the answer. B. Yeah. B is the correct answer. Going to the next. A 4-bit triple adder designed using standard cells shows a worst case ratio delay of 1.5 nanoseconds. If the if the carry chain delay of each full adder is reduced by 20%, what is the new worst case delay? Okay, here we are reducing the carry chain delay of each full adder by 20%. What is the full delay? Okay, here we will see the solution. We have reduced the delay by 20%, so means 0.8 we have to multiply new delay into old delay into 0.5, right? Oh, yeah, it's almost, because in each stage we have reduced it by 20%, right? If it is not each stage, then we have to calculate it separately, right? So correct answer is A. Yeah, correct answer is A. In the dynamic CMOS logic gate, what is the primary reason for the charge loss on the dynamic node? So we have the different option like lock screw, sub-threshold leakage, parasitic inductions, input coupling through Miller capacitor, right? So correct answer is B, I guess. Yeah, threshold is charge loss in a dynamic CMOS is basically due to the threshold leakage. In SR latch is built using cross-coupled NOR gates where S value is 1, R value is 1 simultaneously. What is the behavior? Last one, I guess. Yeah, B. Yeah, same. SR latch, this is like a general question only, right? Invalid case, so unpredictable. This is the answer, it's D here. And it was asked in the gate also a few years back. And next question is in a melee FSM, output glitch are mostly like when the transistor occur at the same clock edge, inputs changes near clock edge, output depend only on the percentage stage. FSM uses one hot encoding. B. It melee stage depend on the inputs also, so it is not like that. It is depend on the percentage state only, and glitch occurs at the input changes near clock edge. So answer is B1. This one. This one. Clock edge. Input changes near edge clock. Okay. In the CMOS, short circuit current occur primarily when NMOS and PMOS are fully on. NMOS is on, PMOS is off. PMOS is on, NMOS is off. Both are partially conducting through the three input transistors. So correct answer is D. Yeah, occurs when both are partially on during the transition. Next is which type of adder has the least delay of 32-bit addition in standard cell ASIC design? Okay, which have the least delay? I guess C. Okay, D is just showing. Okay. Fastest 32-bit adder. Okay, best answer is D. Okay, this is a new adder, I guess. Okay, so you have to just read it about this adder also, right? So mostly like a student maybe will be tick C, but here the answer is D. You have to search it about this adder. What is it is exactly, right? You can just Google it. It is easily available, right? And then you can compare. Okay, metastable flip-flop event in a flip-flop most strongly depends on clock duty cycle, setup and highlight hold violations, frequency of asynchronous input, clock screw tray, clock screw only. Okay. Metastability depends on the hold, setup time and hold time. So answer for this is B. Okay. Which architecture allow glitches free switching between the two asynchronous clock or and or mux or mux level sensitive edges latches integrated clock gating circuits, and last one is mux. Okay, so answer for this is D. So here the questions are object like this part one is only like hardly one numerical is there, right? And mostly are the theoretical ones. But here you will learn some new concepts, like this one is new concepts for you. I guess this one is new concept for you, right? So, and these are the questions. This you can mark in 5 seconds only if you know the answer, right? So that's why we are putting the questions, and by this you can do the revision also, right? So these are important. So this is the part one we have discussed. Here we will see the part two. Part 2. Okay, we have the part 2 solutions also. Yeah. Okay. In the part 2, we have the 11th questions is a latch-based pipeline show time boring. This is also very good concepts in latches, right? This features reducing maximum clock frequency, allow negative screw to be beneficial, increase setup time, requirements, removes needed for a hold time checks. So correct answer is B. Latch up, latch transparency allows negative screw beneficial. So allow negative screw to be beneficial, right? So correct answer is B here. Which of the following increasing dynamic power the most? Which increasing the dynamic power is the most? So high supply voltage, capacitor value, larger capacitor value, or frequency? Half CV square into F, V square. All equally are not correct, I guess. First one is the answer. Yeah, okay. All matter. Okay. It is asking for the most, all equally affect 11th. You can see the answer because formalize this half CV square into F. But it is asking the most. It is asking the most. The answer should be the first, right? Answer should be the A, but it have not given that it will increase 2 times, 4 times, so like that. You should know the concept, that is important, right? So answer is according to me is A, or like you should know the concept, that is a thing. In the exam time they will give the values also, so don't worry. Fine. Next question is, gray code counter is used because it simplifies combinational logic, minimize switching activities, avoid glitching drawing transistors. Answer is A. Answer is, see the answer, D. Okay. Gray code counter, one bit changes at a time. Okay. Fine. So no glitches are there. Glitches will be reduced. So answer is D. Here answer is D here. Okay. If a combinational block have the contaminated delay of 200 ps and next transistor have the whole time of 150 ps, what must be the clock screw satisfy क्या करना पड़ेगा? It is should be, screw should be greater than the 50 ps, lesser than 50 ps, lesser than 150 ps, no constraints. So answer for this is, it is should be lesser than the 50 ps. To avoid, this formula we are using, actually this formula we are using, right? This equation, that contaminated time plus screw is greater than the whole time, right? So if we put all these value, then it will come like this, right? So this is the formula we have. Yeah, here we have the formula. This formula we are using here. Okay, fine. B answer. For a carry select adder, the delay is minimized when the block size flow follows equal size blocks, increase arithmetically progressions, partition rule, and some partition rule is there. You can just search it on YouTube. Oh, sorry, search it on the like. Okay, some partition rule is there. Okay, you have to check it once. Geometric progression, GM, GP series. Okay. Okay, this is also one new good concept for you. Delays in carry ripple adder optimization partition will be minimized by the this rule. So just Google it once, you will learn a new concept here, right? Uh, in a tri-state bus conditions cause floating nodes, excess current flow, is slow transitions, better noise margin. So I guess B answer. Yeah. Two driver zones means exceeding currents, right? So B is the correct answer. Uh, in a transmission gates based, latches is transparent when enable is 0, enable is 1, clock is high only, depends on size ratio. PMOS PMOS by NMOS ratio sizing, right? Okay. Mm. When the transistor, it is unable, right? So answer is first one, right? Answer is first one here. Which of the is not a hazards? Okay, we have the static hazards, dynamic hazards, we have the static 0 hazards, static 1 hazards, but metastability is not a hazard, right? So answer is D. Answer is D, right? Which flip-flop consume the least dynamic power at high frequency? Okay, master slave, T flip-flop, uh, pulse triggered, okay, ace triggered. So we have to check the answer. Pulse triggered. Pulse trigger reducing switching. Okay, pulse triggered is the answer, right? That's why we are using in other applications like others, metastability and all, where we can reduce it, right? Okay, last question we have. In a synchronizer chain, the MTBF improved by reducing clock frequency, increasing flip-flop gain bandwidth, adding more synchronization stages. So the correct answer is all of above. More stages, low frequency, high gained bandwidth, sorry, high gained bandwidth, all it will help to improve the MTBS frequency. You can learn about MTBS also. This is the part of the this metastability and all only, right? Right. There is formula also where you can calculate the MTBS, right? So we have the next part. In the third part, we will discuss the advanced question of FSM, CMOS, hazards and ledges. These are important topics. And in the next week or coming weeks, we will going to upload the combination and sequentials questions also with the followed by the video of the solutions, right? So here we have covered the mostly theoretical part. In the part 5th of this video, we will discuss the numericals also, some of the numericals, right? So going to the part 3. Part 3 is here. FSM based question we have. A one hot encoded FSM has 12 stages. Due to the glitch, 2 state bytes briefly become 1. What is the most likely output? Okay. FSM autocorrects to the next stage. FSM enter metastability. FSM transitions to the non-encoding illegal stage. Output becomes stable but wrong. Answer is D. One stage FSM with 2 ones is illegal stage. Fine, because become, yeah, here we have mentioned, right? Okay. At a time we have to become one stage 1, right? A Mealy FSM produce output depend on the input X. If the X changes 50 ps before the active age of the clock and the logic delay is 180 ps, what occurs? Glitch free output for output glitch for one cycle, metastability, or no glitch due to the clock gating. Glitch will be there. So input changes clock to answer is B. FSM plus late output. Okay, glitch will be there. Okay. Glitch for one cycle. Okay. Yeah, glitch will be there. Okay. A more FSM is converted to the Mealy to reduce the number of state. This risk is introduced. The risk introduces increased area, reducing maximum frequency. Output glitches is more on a asynchronous input changes, increase state bits. So which is the correct answer here? C. The number of glitches depends on the input. If we are increasing the input, then it will increase the glitches. Output glitches on asynchronous input. Okay. So here the glitches will be different, right? C is the answer. A bit encoder FSM has the next stage logic depth of 5 gates. One hot version has a depth 2 if each gate is 50 ps, which is true. One hot is slow, binary is faster. One hot run 150 ps faster, one hot run 250 ps faster. So you just have to see the answer. Is D. Okay, okay. For binary, we have the 5 stage, right? We have the 5 stage for binary. So depth calculation is 5 into 50, which is 5 into 50, which is 250. And for the one hot glare, we have the two gates are there. So yeah, one hot have the two depths are there. So multiply by 2 is 100. So difference is 150 ps. So means answer is C. One hot runs faster 150 ps faster because delays are less, right? Depth is less. Uh, it's simple only. It was simple only, right? CMOS NAND gate has 3 NMOS in series and 2 PMOS in parallel dominance, which is the maximum source of the delay, right? Okay, okay, okay. PMOS network, NMOS stack, threshold voltage drop, Bode effect on PMOS. Okay, so answer is here B. NMOS series stack is equals to the dominance delay. So in NAND gate, right? So this is the one new concept for you. You can just check it once also. Dominance delay in NMOS series stack. Okay, because in series also. Okay, it has the dominant factor here, NMOS stack. Okay, this is one new concept. In a dynamic CMOS, which condition cause full discharge of dynamic node unexpectedly? Weak PMOS leakage, charge sharing between two internal nodes, higher clock frequency, reduce supply voltage. So answer is B here. Charge increase between two internal nodes which have the maximum voltage unexpectedly. Yeah, charge become two internal nodes. Charge sharing reduces voltage. Okay, yeah, charge. Okay. B is the answer here. A pseudo NMOS inverter consuming static power when PMOS is off, NMOS is on, PMOS is on, NMOS is off, both are on, never consume static power. So answer is C here. Direct path. When the direct path is there, means we have the both are on, so it will consume static power when both are on, right? Direct path is there. So answer is C here. In CMOS gate, increase W by L ratio of NMOS by 3x and PMOS by 1x causes okay faster rise time, slower fall time, slower rise time, faster rise time, both ages faster, both ages slower. So we have seen this concept in the part 1 also, right? If you know, right? So answer is B here, because the thing is fall become faster as it depends on the fall time become faster because it depends on the this one and most, right? And rise become slower, right? rise rise time becomes slower. We have seen this in the 28 it is. We have seen this concept in the part 1. Yeah, yeah, rise time depend on the PMOS. Okay, this was PMOS and NMOS, right? Fold time depends on the NMOS. Okay, this is the similar concept you can see, right? So answer is B here. Answer is B here. This one is B. Sorry, it's one. Hazards. There are different type of hazards: static, dynamic, functional. Um, a, a circuit exhibits 0 to 1, 0, 1, 1, 0 transitions for a single input change. This is static 0, static 1, dynamic, functional hazards. So yes, this is dynamic. This is dynamic. If it is constantly become 1 or constantly become 0, then it is static, right? But here it is changing constantly, so it is dynamic, right? We have the next question. Static 1 hazards occur due to multiple paths with unequal delay, uncovered min term in K-map, simultaneously input changes, clock screw issues, right? So answer is for this is B. Min term causes missing constant terms are uncovered min terms, right? So answer is B. Here is also one good concept that you can remember, right? So this is also one new thing for you, right? Gray code counter eliminates hazards primarily because of only one bit changes at a time at one and at per transistors. Uses melee FSM, uses binary encoding, no recurrence pen out. So answer is A, I guess. Yeah, answer is A here, right? Going to the next. A logic function has three paths from input A to output Z. Worst case hazard trick is when uh, all paths are balanced, then it is not hazard. It will not that much big group will belong. On inputs or one path is much faster. All input changes simultaneously. That is also not an issue. Output uses NAND structure. I guess B is the correct answer. One path is much faster, right? Unequal path delays, right? Yeah, B. So going to the part number 4. Part number 4, we have the latches. Okay, and then we have the metastability. After that, we have the last part is 5th. Okay. First question is here the a latch, a label sensitive D latch shows a transparency for 350 ps during clock high. If input toggles twice during this window, output follows both toggles. Output captures first toggle only. Output capture last stable value before closing. Output become metastable. Output become metastable. Okay. 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 So correct answer is, which question number is it is? D. Output become metastable. 33. It should be 33. Yeah. Output become metastable. Here they have that given the explanation. Transformation. Finally input changes it. Okay. So it become metastable, right? Note on the final value. Latch-based design enable time borrowing. Maximum time borrowing occurs when launch and capture latches open simultaneously. Duty cycle increasing, hold time increases. Next stage latch open early. So this is very important concept we have. Time borrowing concept in latches, right? Sometimes they ask in the interview also, what is time borrowing concept in latches? When they will ask the question, what, tell me the difference between latches and flip flop. Next question they will ask time borrowing concept. If you able to answer, like, you can predict questions accordingly, you are giving the answer, right? So that is one good concept here, time borrowing concept. So correct answer is A here. Launch and capture latches open same time, right? Latch enable time borrowing. Maximum time borrowing will be at the when the launch and capture latches open simultaneously, right? There is one diagram also, waveform diagram, that you can see, right? Right. You will easily get the one video on the YouTube channel, on I guess some other YouTube channel is there, or just Google it. That it will hardly take 20 minutes to learn this concept, but this is very important concept. Okay. Transmission gate latch voltage drop issue is eliminated because PMOS compensates NMOS threshold, body effect removes threshold, gate control leakage is zero, noise margin is high. So answer for this is, okay, this is metastability. Okay, the answer is 1. A means this NMOS compensates PMOS threshold. Voltage drop is eliminated because of the PMOS compensate NMOS threshold, right? Here is the explanation they have given, right? uh, Flip-flop metastability. Okay, this is the concept. Metastability resolution time decreases when clock frequency increases, supply voltage reduces, gained bandwidth of flip-flop increases, flip-flop internal feedback weakens. So correct answer is C here. So high gain bandwidth is speeds resuming, right? So correct answer is this, right? So yeah. So resolution time depends on the bandwidth mainly, right? Gained bandwidth margin, gained bandwidth, right? In CDC synchronizers, the most metastability safe method for multiple bit data is 2 flip-flop synchronizer per bit, gray coded point flip-flop, 1 hot encoding latch-based synchronizers. So correct answer is, it is asking about the multi-bit, right? Multi-bit. So it is the B, because gray code counter changes 1 bit at a time. So for the multiple bit, we have the best solution is gray code counter. Answer is B here. MTBF improves exponentially with lower temperature, most flip-flop stages, higher fan out, reducing clock screw. So correct answer is exponentially is more stages. Answer is B here. Answer is B here. MTBS exponentially improves if the more stages are there. Other methods you can also see. It depends on other things also. A flip-flop enter metastability if setup time, hold time satisfied, but high clock jitter, input toggles exactly at clock edges. No, okay. Clock screw is large, reset is asynchronous. B, I guess. Triggered when inputs right at toggles at the corner edges, right? Best curve for metastability when dealing with asynchronous input are when external input is delay, add delay elements, use Smart triggered, use two flip-flops, two FF flip-flop, two flip-flop synchronizer, use use latches and flip-flop instead of flip-flop. So answer should be C. Two flip-flop synchronizers, best course, right? So you can just check it also if you don't know the answer, because these are theoretical things, right? You have to learn the concept in depth. So one concept we have seen it is time boring here, and one concept metastability, that is very important. And CDC, obviously if you are learning metastability, you will able to learn the other things also, like CDC, gray code counters, uses of gray code counters, all these things, and synchronizers also, right? So in the last part, this is the numerical based mainly, right? This is numerical based mainly. uh, Not a diagram is not there, simple calculation is there. So these are the simple but direct questions. uh, we have the propagation delay. Propagation delay is the concept name here. CMOS inverter have load capacitor, uh, PMOS resistor, NMOS resistor. The word propagation delay. Okay, we have to tell the most propagation delay for this concept. So for the worst propagation delay, we have the PMOS resistor into capacitor. So answer is this, right? You just have to multiply this with the PMOS. Yeah, answer is C. Yeah, right. Okay. We have the noise margin calculation. We have the VOH 1.2 voltage, VOL 0.2 voltage, 2 volt, sorry, and VIH is 0.9 volt, VIL is 0.4 volt. The noise margin low limit we have to tell. So there is direct formula of noise margin that you have to remember. Sometimes they will ask in the exam for the calculation, but if you are giving theoretical or if you are giving in the interview, but generally they don't ask noise margin in the interview. But if you are dragging that to that side, they will ask this question, right? Generally they don't ask noise margin in the interview, but test they will ask the formula. There is diagram also of noise margin that you have to remember, right? So formula for this is VIL minus VOL 0.4 minus, this is directly formula based question. B is the answer. We have the RC delay in AND gate concept. We have 3 input AND gate issues, 3 NMOS in series. Each NMOS resistor is 2 kilo ohm. Load capacitor is 30. What estimated the worth rise delay? We have to tell the worth rise delay here. Simple. We have the the capacity 3 stages. So we have to 4 plus 4 plus 4. This is 6, and after it is we have to multiply with the capacitor value. So it will be multiplied by 30. So answer is C. Fine. This is simple only. This is what, this is the things they are asking, right? You have to focus on this thing also, right? This, right? If they are asking something, maybe formula will be different, right? Dynamic power calculation, this is very important, right? And this we have already seen the formula. We have given the frequency, we have given the capacitor value, we have given the voltage value and the toggle rate, right? So dynamic power formula, this toggle rate into half, sorry, this is not a half. We have the half for the generalized static power mainly, right? But here the toggle rate is 4. Don't use half here, right? Because this is dynamic, right? So 0.4 into capacitor into voltage into frequency, right? So correct answer is this one. This is the dynamic power, not static. If it is asking static, then half. Critical path, or they have not given the toggle rate, then you can use a half also. Critical path delay for adder carry, ripple carry adder 8-bit. We have given the full adder carry delays. What is the worth delay? Worst delay, right? Worst case delay. So we have to see it. Just multiply it. Just multiply it. Carry, ripple carry adders are the stages. So we have to multiply it once. Simple. So answer is B. Hazard condition, 2 paths are there. Path 1 delay is 400 part 2 delay is 120. If the input toggle, how much delay it is asking? Pulse width it is asking, right? So just create the difference. Pulse width is the difference of the this ways only, part 1 and part 2, right? So metastability calculation, uh, we have the formula. We have seen this MCBF recently in the previous part also. So we have here the formula, generalized formula we have. So we have to just calculate it once, right? So we have the theoretical, we have seen the theoretical concept also. We are seeing the formula based question also, right? Of related to the metastability, right? So they have given the formula also. They are asking to me calculate the exponential. So sometimes they give the like they give the calculator, sometimes they don't give the calculator. So we have to like maximum value options. Okay. So this is a formula based question only. So they have ticked the A one, right? So you just have to put the values in the formula. That is a simple thing. They have done it, right? But see the formula nicely. Also see the book formula you have, right? Not in the exponential form, right? It is available, right? Latches transparency time. Latches enable higher for 315 ps input changes at 1 ps, 100 ps, 250 ps, 300 ps. Which value is latched? Initial value, value at first change, value after second change, value after third change. Again, good question. Last stable value, it will be it should be answer like last stable value, but before this, right? So answer is last D1, right? If it is under 400, then it is also 300, right? Setup time, hold time calculation. Okay, we have given the setup time, screw time we have given, and we have given the delay part, data part delay. We have to calculate the clock period, minimum clock period. So we just have to so just see the equation of setup time, hold time. That is very important, because sometimes direct in the test they will ask the direct where you have to put the value of hold time, setup time and clock. You can direct numerical will be there, and equation will be also helpful in the interview. If you write it in the, when they ask the question of what is setup time, hold time, it is not only definition, you just have to tell the equation also, right? It will be very important, right? So minimum clock period is here. We just have to add everything, right? So yeah, but see the formula, that is important, right? Here they have not written the formula. If you check the formula also, you will get one formula also, right? Last question of this series is contaminated delay and hold time given. Contaminated delay 90 ps, hold time 150 ps. To avoid setup time, screw should, again same question that we have marked in the part 1. This is a complete formula based question. This is a complete formula based question, right? I will see this thing also in the part, this one, I guess part 1 or part 2. We have the different condition for setup time, we have the different condition for the hold time. We have to we have to avoid metastability, both should be satisfied, right? So this is the formula that they are using. Contaminated delay time plus screw should be greater than the hold time, right? So this is the final answer, that screw should be lesser than setup time minus this thing, sorry, hold time minus contaminated delay. So answer is A. Yeah. So these are the few questions. Average student can answer, I guess out of 50 you can answer 30 correctly, 30 to 35. But there must be 5 to 10 questions which will be new for you, which will help you to revise the new concept or the old concept, right? So these are very, very important. So go through it. If you have any further doubt, if you have the request that make the video or put the questions up, MCQs related to this topic, then just comment out. We will make the video accordingly according to that topic also. Fine. So thank you. Have a nice day. If you have any doubt, you can just contact us on the WhatsApp, or you can go to my LinkedIn account also. This is my LinkedIn account. Okay, this is the page. This is my LinkedIn account. You can go to the VLSI Rajat Kumar Singh on VLSI for all, and just click it here. Free counseling. It will redirect to my personal WhatsApp. Just drop your query within 2 days, within maximum 1 or 2 days. I will going to call you, right, and resolve your doubts, right? So thank you. So all the best. Have a nice day.